Operational use of ECDIS. Operational use of the Electronic Chart Display and Information System, ECDIS. ECDIS is one of the most important navigation systems used on modern ships. It replaces paper charts with electronic charts and helps navigators plan routes, monitor voyages, and improve safety at sea. Course Overview. This course introduces the basic operation of ECDIS. It explains how electronic charts improve navigational safety by displaying real-time information. ECDIS also integrates different navigation equipment such as GPS, radar, and AIS, allowing officers to monitor the vessel more efficiently during a voyage. What is ECDIS? ECDIS stands for Electronic Chart Display and Information System. It is a computer-based navigation system that uses electronic navigational charts, ENCs, instead of paper charts. It continuously displays the ship's position and assists the bridge team in making safe navigation decisions. Purpose of ECDIS. The primary purpose of ECDIS is to improve navigational safety. It reduces the navigator's workload by automating many navigation tasks such as route planning and route monitoring. It also provides better situational awareness by displaying important information on one screen. ECDIS interfaces. ECDIS works together with several navigation instruments. GPS provides the ship's position. AIS displays nearby vessel information. Radar/ARPA detects targets and collision risks. Eurocompass provides heading. Echo sounder measures water depth. Weather and tide information helps officers make better voyage decisions. Because all these systems are connected, ECDIS becomes a complete navigation platform. Benefits of ECDIS. ECDIS offers many advantages, including faster route planning, continuous route monitoring, automatic estimated time of arrival, ETA, easy updating of electronic charts, automatic voyage recording, safety alarms that warn the navigator of potential dangers. These features increase both efficiency and safety. Basic elements of ECDIS. For ECDIS to function correctly, it requires a position sensor, GPS, a heading sensor, a speed sensor, IMO-approved hardware and software, official electronic navigational charts, ENC, properly trained navigation officers. Without these components, ECDIS cannot provide reliable navigation information. ECDIS alarms. ECDIS automatically warns the navigator whenever danger is detected. Examples include exceeding the cross-track limit, crossing the safety contour, route deviation, approaching a critical point, power failure, system malfunction. These alarms help prevent accidents but should never replace proper watchkeeping. Setting up ECDIS. Before every voyage, ECDIS must be properly configured. The officer should verify the position system, check display settings, update electronic charts, set safety parameters, configure alarms. Incorrect setup may lead to unsafe navigation. Safety settings. The four most important safety settings are safety contour, safety depth, shallow contour, deep water contour. These settings allow ECDIS to distinguish safe water from unsafe water according to the ship's draft. Safety contour. The safety contour separates safe water from unsafe water. Formula. Safety contour equals ship draft plus squat plus UKC minus height of tide. When the ship approaches or crosses this contour, ECDIS activates an anti-grounding alarm to warn the navigator. Safety depth and CATSOC. Safety depth highlights dangerous soundings that may be unsafe for the vessel. It is normally calculated as ship's draft plus squat. CATSOC stands for Category Zone of Confidence. It tells the navigator how accurate the hydrographic survey data is. Higher catch-up means greater confidence in chart accuracy. Capabilities of ECDIS. ECDIS has many capabilities. Displays the ship's position in real time. Plans safe routes. Monitors voyage progress. Displays radar overlays. Integrates AIS information. Calculates ETA. Updates electronic charts automatically. These features make navigation more efficient. Limitations of ECDIS. Although ECDIS is powerful, it has limitations. Examples include sensor failures, incorrect chart data, system lag, limited chart coverage, human error, over-reliance on technology. Because of these limitations, navigators must always verify information using other navigation methods. Raster versus vector charts. There are two main electronic chart types. Raster charts. Digital image of paper charts. Cannot be edited. Lose clarity when zoomed. Vector charts, ENC. Digital database. Can zoom without losing quality. Interactive. Preferred for ECDIS navigation. Loading chart data. Electronic charts may be loaded using CD, DVD, USB drive, network download, internet download, manual input. Charts should always be updated before sailing to ensure accurate navigation. ECDIS functions. The main functions of ECDIS include displaying electronic charts, planning routes, monitoring vessel position, generating safety alarms, determining ship position, recording voyage information. These functions help officers navigate safely throughout the voyage. System integration. ECDIS integrates information from GPS, radar, AIS, echo sounder, Navtex, weather systems. This integration provides better situational awareness, supports decision-making, and improves navigation safety. Over-reliance on ECDIS. One of the greatest dangers is relying too much on ECDIS. Officers should never trust alarms blindly. Ignore visual lookout. Ignore backup navigation methods. Use incorrect safety settings. Forget traditional navigation skills. ECDIS is an aid to navigation, not a replacement for professional judgment. Key takeaways. To conclude, ECDIS is one of the most important navigation tools on modern ships. Proper setup and regular chart updates are essential. Understand both the capabilities and limitations of the system. Always combine ECDIS with visual observation, radar, paper backup when required, and good seamanship. Remember, ECDIS helps the navigator, but the navigator remains responsible for the safe navigation of the ship.